Okay, I'm going to go ahead and do some of our homework problems from our abstract algebra course, which is using the book A First Course in Abstract Algebra by John Fraley, 7th edition. And I'm just going to go ahead and work number 29 and 30 from our homework in section 0. Okay, number 29. These two exercises here, 29 and 30, determine whether the given relation is an equivalence relation on the set. Describe the partition arising from each equivalence relation. So what do we need to do here? If we have an equivalence relation, then we know we basically just have to check to see if it's reflexive, symmetric, and what's the other one? Transitive. Okay, so looking at number 29, we have N is an equivalence relation to M. In the book, I'll just make a quick note. In the book, you got this really super hard to draw, fancy, squiggly R right here. So in class, we're just using this right here, which is a lot easier to draw than this really crazy font. So that is the same thing there. So N is an equivalence relation to M in Z if N times N is greater than 0. Well, let's check if it's reflexive. Okay, alright, let's check reflexive. Reflexive, I'll put a little question mark. Okay, so this is basically just using N times itself. N times itself. So N squared. N squared always greater than 0. Greater than 0 for all Z. So if N would equal 0, 0 squared is not greater than 0. It's equal to, but we weren't given the equality sign along with that. So this one fails. Fails the reflexivity, so it's not an equivalence relation, not an equivalence relation. But let's go down and do number 32, which is one of our problems. 30. Okay, let's see if this one works. We got X, an equivalence relation to R. X is an equivalence relation to Y in the reals. Now we're dealing with real numbers. If X is greater than or equal to Y, this may change some things here. Let's start checking the properties. Does this have the property of reflexive? Is it reflexive? Reflexive? Or reflexivity would it be? I'm not sure. So X in relation to itself, because X is greater than or equal to X. Yeah, pretty much. You got the equality in here, so this checks off. This is true. Is it symmetric? Well, let's check. That means if you have X is an equivalence relation to Y, then it logically follows that Y is an equivalence relation to X. So plugging those values into here, if x is greater than or equal to y. If that's true, does that imply that y is greater than or equal to x? Okay, this is not symmetric, is it? Because in our first example, if x is 4 and y, let's just say it's 3, that satisfies this. Well, that doesn't mean that 3 is greater than or equal to 4. So, once again, this fails symmetry. We'll just say it fails number 2. So, once again, this is not an equivalence relation. And I'm just going to, not an equivalence relation. Okay, I'll do a couple more in a little bit.